Okay, 2.5 is called solving compound inequalities. So a compound inequality is when we have two inequalities that we're going to join together, and you have to use the word and or the word or. So we've got two basic brands and they're illustrated here. First we've got our and version. So here we have x is greater than 2 and x is less than 5. And if you use your imagination, there are numbers that fall into both those categories, right? Like the number 3 is more than 2 and less than 5. So you can join these together like so. So I've got numbers between 2 and 5, and 2 and 5 aren't included because there's open dots just like there. So those and ones are going to join together like that, okay? When we've got the or ones, they're not going to join together. They're going to go outwards like this. So if we think about this, x is less than 3 or x is greater than 6. You have to use the word or because and doesn't work. If you think of a number that's less than 3, 2 for example is less than 3, but it's not greater than 6. There are no numbers that are less than 3 and greater than 6, so you got to use the word or, and that means your solution is going to be separated like that, but you can still graph them on the same number line, okay? All right, so first let's talk about how I can take this compound inequality. I've got these two inequalities joined by the word and I can write them as a single inequality, okay? So 3 and 9 are called the dividing points. If you were to graph this on a number line, 3 and 9 would be the important points, like 3 and 6 are important here, or like 2 and 5 are important here. So what I like to do is line those up from least to greatest and leave some space in between them. So 3 is less than 9, right? So it'd be to the left of 9 on the number line, okay? And then I'm going to want x to be in between those two things. It's always going to work out like this with the and ones, all right? And then I just need to put in my symbols. So I'm going to put some inequality symbols in these two positions. Let's start with the x and the 9 because that's actually easier. What I do is go look over here. It says x is less than 9. If you think about the alligator eating the bigger number, the alligator's eating the 9. So I want that still to happen here, okay? With the x and the 3, the alligator is eating the x, okay? So that means I want this to happen, okay? Because I could flip this inequality around like so, and I'd still want the alligator eating the x. It would look like that, right? So now I've got this written as one inequality. You could flip this whole thing around, and you'd have to flip the arrows as well. So would look like that. You could write that. That wouldn't be incorrect, but it's usually written with the smaller dividing point on the left, the bigger one on the right, which means the arrows are going to be going to the left like that, okay? All right, you can't write the ones with or as one inequality because both things can't happen at the same time. All right, so let's look at some examples here. We're going to write some sentences and then graph the inequality. Okay, a number x is more than 1 and less than 7. All right, that word and is telling me, hey, it's going to look like this as opposed to like this. So I kind of know that right off the bat, that it's going to be one of the ones that's joined in the middle. But let's break this down. It says x is more than 1. All right, x is more than 1. So x is greater than 1. That's the same as saying x is greater than 1. It can't be equal to 1 because it's not more than or equal to, it's just more than, okay? And then also x is going to be less than 7, okay? So you could write if you're just asked to write the solution, you could write it like that, but we can also put those together into one inequality, just like we did up here. So got 1, then my x, then my 7. So I have the smaller number, then the x, then the bigger number, okay? Then looking at the x and the 7, alligator's eating the 7. Over here, alligator is eating the x. Between the 1 and the x, alligator eats the x. So there's my solution, okay? So then let's graph this. So I like to graph above the number line with my points floating above the number line, kind of like up here. Some people do it right on the number line. I find then it's hard to tell if the dots are open or closed. So I've got above the 1, I'm going to put an open dot because that's not an included point. My inequality symbol isn't included there. Same thing with the 7, okay? And so, I got numbers greater than 1. Those would be over here. Numbers less than 7 would be over there. And if you want numbers in both positions, going to be in between 1 and 7, like so. Okay? All right. Next one. X is fewer than negative 5 or no less than negative 2. Okay? X is fewer than 5. Fewer than negative 5. That's the same as saying x is less than negative 5. And no less than negative 2. That would be the same. So that means it can't go below negative 2. So it could be negative 2 or anything more than that. That's the same as saying x is greater or equal to negative 2. Okay? And this is an or one, so I can't combine these into one statement. But now I've got enough to graph this. So I've got an open dot above the negative 5. Okay, and its numbers less than negative 5, like negative 6 or negative 7. They would be going that way. And then I've got a closed dot above the negative 2. And its numbers greater or equal to negative 2, so those would be numbers over there. Okay? Okay, on the next page, we're going to solve some of these compound inequalities. So yeah, we're going to solve this and then graph it on the number line. So when we're solving these, we want to isolate the variable. So I want the x to be by itself, okay? Now, if you imagine if I had just an inequality like this, and I wanted to solve this inequality, to get the x by itself, I'd subtract 4 from both sides of the inequality, okay? I can do the same thing here, except I'm just going to subtract 4 from all 3 of the sections. So I'm going to be subtracting 4 here, and here, and here, okay? And then let's see, 5 minus 4 is 1. Got that symbol then. And then I'm just left with x in the middle because those 4's cancel. 10 minus 4 is 6. Okay, so this is my solution. So let's go ahead and graph it. Above the 1, I'm going to have a closed dot. Above the 6, I'm going to have an open dot because that's not underlined. Okay, so the 1 is included, the 6 is not included. And then if you think about the x's, they're going to be greater than the 1 because it says 1 is less than or equal to x. So that means x is greater or equal to 1. And x is going to be less than 6. So less than 6, greater than 1, that puts me in between those two. And there we go. There's my solution on the number line. Okay? So just like the last problem, I want to isolate the x in the middle here. So I'm going to start by adding 5 to all 3 pieces of this inequality. Let's see, negative 3 plus 5 would be 2. Those are going to cancel, so now I just have 2x in the middle. 7 plus 5 is 12. And then I still need to divide everything by 2. And heads up, if you ever multiply or divide by a negative number, you'd have to flip the inequality symbols. But since we're dividing by a positive 2, you don't need to flip the symbols here. So now I've got 2 divided by 2 is 1. 2x divided by 2 is x, and 12 divided by 2 is 6. This is my solution. So both of these are going to be open dots. Okay, and it's going to be numbers between 1 and 6 because my x's are going to be bigger than the 1, but less than the 6. So there's numbers in between. Okay, all right. So those last two we did are and ones because we've got both things. It's written as one inequality. That's how I know it's an and. These or ones, you can't write them as one inequality, but I can still just solve both of these separately. So this is an or one, so I just got to solve both of these separately and then put them on the same number line. Okay. So I'm trying to isolate the x here. I'm going to subtract 3 from both sides to get rid of the 3. So now 4x is less than or equal to negative 8. Negative 5 minus negative 3 is negative 8. And then I'm dividing by 4. And again, I'm not dividing by a negative, so I don't have to flip anything here. So I have x is less than negative 2. On the other side, all I have to do is add 8 to isolate the x. Those cancel. And I'm just going to write it down here so that I can write or. So I'm left with x is greater than 7 over there. So this is my solution. And now I'm going to plot that. So above the negative 2, I've got a closed dot. And I can follow the directions of the arrow. The numbers less than negative 2 on the number line would be down there, right? And above the 7, I have an open dot, and numbers more than 7 are going to be to the right. Those or ones should be pointing outwards. Okay. All right, let's try another here. So let's see, I'll subtract 1 from both sides here. Whoops, subtract 1. Then 2x is less than negative 8. And divide by 2. X will be less than negative 4. Okay, on this one, trying to isolate the x, let's get rid of the 3 first. So this is another or, right? I've got to solve these separately. Those cancel. Now I have negative 2x is less than or equal to negative 4. Okay, so now I'm going to have to divide by negative 2. And when we divide by a negative, that means that this symbol has to flip around. So be careful, that's easy to miss that. So I flip that symbol around. Okay, those negative 2's cancel. Now I got x is greater or equal to positive 2. And I want to put the word or between the two parts of my solution. Okay, so above the negative 4, I've got an open dot, an arrow going this way because that's numbers less than negative 4. And then numbers greater or equal to 2. So a closed dot and numbers bigger than 2 would be to the right. And there's my number line solution. Okay, that's it for this section, and I'll see you next time.